Okay, finding the domain of square root functions. When we're dealing with square roots, we're basically looking at three conditions. You have square roots of positive numbers, the square roots of 0, and square roots of, let's say, negative numbers. When you take the square root of positive numbers, you get a real solution. A 2 is a real solution. Even if it had decimals, that'd be real. Square root of 0 is 0. That's a real solution. But when you take the square root of negative numbers, you get non-real solutions. So this is no real solution. So we try to avoid this situation right here. And in order to only look at numbers that are either positive or 0, we have to say that what's under the radical, which is called the radicand, has to be greater than or equal to 0. So we're going to use this process here to find the domain, or what numbers can be used for input. Okay, so the square root of x plus 4, what numbers can be used for input? Well, we'll say that x plus 4 has to be greater than or equal to 0. Then we'll use this to solve for x. So minus 4 on both sides, and we get x is greater than or equal to negative 4. The graph of this looks like this. Here's a number line. There's negative 4. And since it can be equal, we're going to make a solid dot. That means negative 4 can be used in the original equation. And greater than negative 4 means all the numbers to the right here. So these are all the numbers that can be used with this equation right here, or possible numbers, which makes it the domain. So I'll label my domain will be the negative 4. We'll include the negative 4. And everything to the right here, which will be infinity, and we always use parentheses. So there's the domain for this function. Okay, let's look at number 2. Same idea. We want to find the domain of the square root of 2x minus 4. So we'll take 2x minus 4, set it greater than or equal to 0, because of the square root. And we're going to solve for x. So we're going to add 4 to both sides to isolate the x. We'll get 2x is greater than or equal to 4. Then we'll take our 2x is greater than or equal to 4 and divide by 2 on both sides to get this to become a 1x. It does isolate the 1x, greater than or equal to, and 4 divided by 2, that's an even division, so that's 2. Now the graph of this would be 2 here, and since it's equal, we'll include the 2 with a solid dot, greater than anything here to the right, any number over here to the right. So the domain would be the 2 and anything to the right of 2, any number to the right of 2. That's our domain. Okay, let's take a look at the last one here. We have a square root of negative 5x plus 40. We're going to take the negative 5x plus 40, set that greater than or equal to 0, and then we're going to solve for x. So subtracting 40 from both sides will give us a negative 5x is greater than or equal to negative 40. Then we'll take our negative 5x greater than or equal to negative 40, and we're going to divide both sides by negative 5. Now, negative 5 divided by negative 5 gives us 1x. But there's a rule that says that when you divide by negatives, or multiply by negatives on both sides, you'll get a sign change. So that's going to change from a greater than or equal to a less than or equal to. Okay, so there's a change. Now over here, negative divided by negative will be positive, and 40 divided by 5 is 8. So the domain now will be x is less than or equal to 8. So let me show you the graph of that. Here's what 8 is, and there's an equal sign, so it includes 8, and all the numbers to the left. So I'm gonna write those. Okay, so it includes everything here to the left and 8. So let's say our domain would use numbers to the left of 8 and including 8. So that will be our domain.